I'm not going to take too much time to introduce him because if I started providing the details, we'll be here forever. I'm just going to say this. Professor Jhunjhunwala from IIT Madras, which is the leading engineering institution in India. Let me say, he reached for the stars and actually grasped them. The first time I met him, he was working on communications in India, where we had 10 million telephones, and his goal was 100 million telephones in the country. As of now, we are selling 16 million cell phone lines a month. So he has declared victory and moved on. And he's working on DC and rural electrification, and I can't think of somebody who can contribute more to addressing the issues of the business of humanity than Professor Jhunjhunwala. And he's promised us some very interesting observations today. So he's won every award from the government for what he has done. It's, so I'm pleased and proud to introduce to you the extraordinary Dr. Ashok Jhunjhunwala.
Thank you, John. Thank you. My predecessor was able to give a fairly good understanding of what we will what I'm going to talk about. We are somewhat familiar with what is going on in data centers. But our problem, we do use data centers, and we are utilizing all the things that are being done, what was being talked about. But what I am going to talk about is somewhat different. First of all, my focus will be emerging economy like India. I'm going to talk only about India because that's what I understand. And I'm going to put forward even one stronger than what was put forward, that has time come to switch to DC power at customer premises, at least at customer premises. I'm not saying therefore you shouldn't use DC transmission. Of course, the generation like solar will certainly be DC, but I'm going to talk about therefore managing power in emerging economies like India. Now, why am I talking about managing power? Because one has to understand India with its billion people. Where is the mouse? Let's understand the power with 1.2 billion people. Electricity. It is an electricity-starved country. Now, how do we understand to what extent it is electricity-starved? Today, there are producers of power, bulk producers of power, who sell their power to the electric distribution companies in a stock market. And every hour, the prices vary depending on what the demand is and what the suppliers are. And every day, the price changes from 2 rupees to 4 rupee 50 paise per unit. 1 unit is kilowatt hour. I'm sorry, I'm going to talk about in terms of Indian rupees. I put the rupee, 60 rupees is $1 US. The reason is that nowadays the rupee has been fluctuating quite a bit, and therefore I didn't want to put some number which would have changed by the time I would have made the presentation. But you have to think a little bit in terms of Indian 2 rupees to 4 rupee 50 paise, something closer to 5 cents or something like that, as the minimum, going up more as we go on, close to that. But that is only part of it. If one looks at any particular week, and I won't say every week, but most weeks, the prices in this power market touch to 12 rupees. Not from 2 rupees to 12 rupees. Now what does this 12 rupees, touching 12 rupees imply? 12 rupees imply that really there is a huge, huge shortage. And by the time, the other point is that this is the price at the source of the generation. So by the time it is transmitted and distributed, another 50 to 60% will get added. So this 12 rupees will become 18 to 20 rupees, which is will close to about 30-35 cents per unit. and basically become totally unaffordable. Now, as a result, what happens is that by and large, India has 2 hours to 22 hours power cut in most of the country. There are few places where there are no power cuts, but most of the country, city like Chennai, for example, was getting 6-hour power cut this summer. Places like Coimbatore, which is one of the large cities in Tamil Nadu, was getting 12 hours power cut. Meerut is a city 1 hour from Delhi, and typically every summer, throughout the summer for about 4 months, it gets 12-hour power cut every day. So the rural areas I'm not even talking about. This is the situation. Now, given this situation, actually it was this situation that got us started working from communications to power. We were trying to put communication systems in rural areas, and power was one of our biggest bottlenecks. And we started looking at it. Just let's understand, what does it cost? What does it cost to a customer? What does a customer do? Customer typically buys power between 5 rupees to 9 rupees. It can go down to 4 rupees if it's highly subsidized per unit. This is the price which by and large the customers can afford. Of course, the grid power is available at God's will. When will it be there, when it will not there, we don't know. And people like us in our offices, whenever the power fails, turn on a diesel generator. What is the cost of a diesel generator? If you take the total cost, the diesel generator, its capex, the interest rate is typically 14 to 15% in India. You need to take that into account and calculate the cost per unit. It comes to 23 rupees per unit. If the diesel generator is being used at full load, most of the time it is not used at full load. If it is used at something like 40 to 50% load, the cost goes to 35 rupees. So instead of paying 5 rupees, you are paying 35 rupees. And this is what most of the country does. Then what about battery backup? That's the second most important thing. Many offices have battery backup. The battery backup also costs around 20 rupees, between 17 to 20 rupees. So suddenly from 5 rupees you are talking about much larger number. On the other hand, if I use solar, what happens? If I have a sufficiently large rooftop and put a solar photovoltaic and use it in the country directly in DC form, my cost is under 5 rupee 50 paise. So similar to the grid number. But if I add AC, maybe another 50 paise. So that itself does add cost, does introduce inefficiency to some extent. Of course, this doesn't take into account the land cost. But of course, solar is available only when it is available. Now, why am I talking about DC? What is the usage in India? If you take homes, the biggest usage is lights. Well, one of the biggest uses is lights. And the lights, we have gone away from the tungsten bulb. We now use CFLs and LEDs. The CFL essentially is neutral to AC or DC. It requires a very high frequency. So whether you use AC or DC, it doesn't matter. So we could use AC or DC. But now we are starting to move towards LED, which is far more energy efficient. LED is actually DC. We have to use it DC. So whenever we use AC, we actually have to convert AC to DC. So there is some reason, if solar is producing DC and light LED is using DC, why not directly use DC? It can become huge saving. That was the first thing that we started thinking. But in India, at homes, the biggest use is fan. A typical fan, AC fan, full-size fan, it consumes 70 watts of power. What is worst is that when you reduce the speed of the fan, very often you run it at half the speed, still consumes about 60, 62 watts. If I replace it by a DC fan, and which we have actually done, it consumes only 30 watts. And when I reduce speed to 50%, it consumes only 50 watts. And essentially this BLDC motor got us moving into DC more than anything else. And we have suddenly find that this is used in refrigerator, this is used in air conditioner. So suddenly we have started working in all these little things one by one. And then we are starting to use electronics increasingly more. Whether it's a television or laptops or cell phone charger. We use 230 volts in India. At 230 volts, when I use a cell phone charger, my typical efficiency is about 35 to 40%. If I use a laptop of HP made, I just got a new HP made, and my efficiency is 65%. So I'm actually wasting power. If I use DC directly, it will be great. Even if I have to do a conversion, I can get DC to DC converter at 90%. So that basically got us thinking that at least at homes and offices can we start switching to DC. Now, then we started looking at, for power-starved country, what can one do? Now, of course, solar is great. I just now talked about DC is great. But let me start. One of the biggest problem is that there is really so great a pull. Why will individual home switch to DC? It's complex. The transmission line gives us all AC. If I start moving to DC, I need converters. And if I start using DC equipment, I need initial investment. And it does not really help me when the power cut takes place. So power cuts is a major problem. On the other hand, if I look from a different point of view, the political parties are all in India need to keep the tariff for electricity low. They cannot increase it beyond 5 rupees, 6 rupees. If they increase it, they will lose elections. Because that's what the people can afford. And the problem is the electricity board, because they are paying even 12 rupees, which costs them around 18 rupees, they are starting to lose money. They almost all the electricity boards, except in 2-3 states where there is plenty of water, and therefore electricity is generated at lower cost. They are losing, they are in red. So subsidized tariff makes electricity boards unviable. Huge power cuts paralyze life. Of course, the upper sections, about 25% of the country uses diesel generator and battery backup, inverters they call it. What about the rest of the country? So how do we incentivize them to use solar and DC? So that basically got us thinking. We had already worked on solar, we had already worked on DC devices like fans and lights, but how do we get things going? And it is at that time, about 5-6 months back, we came to the conclusion that can we figure out a way of providing power to each home 24/7? And I said, well, I will provide you 24/7 provided you use DC devices. Now, that is a big thing. 24/7 can win elections today, power. It's a real major thing. Of course, how do I provide that? We cannot change the grid significantly. Then that will require huge investment. We will provide small amount of power. Small enough so that I can actually use for my lights, fans and electronics. Need not use it for others. And can I use energy efficient DC devices? And can I then supplement with solar? That's a direction that we started thinking. Next 3 slides that I'm going to talk about is somewhat confidential. Somewhat confidential in the sense that it is no longer confidential. I am presenting it here. I have presented it in 1 or 2 places. But we have filed patents and we still have not, we have avoided media. We don't want too much talk. We want to build it and install it before we start doing it in a bigger way. Basically, we have come with an innovative scheme for low power cuts. Now, essentially what we do, at each home, the grid line comes in. The grid line comes in at 230 volts. We are replacing a meter. The standard meter is replacing by what we call a new UDC meter. The UDC meter gives 2 lines. One is the standard AC line, which we are currently using. Of course, if the power is there, then only that line will get power. When the power fails, that doesn't give the power. Plus, we are giving a 48 volt DC. And we'll talk a little bit about why 48 volt DC. It will have a very limited amount of power. Limited, but uninterrupted. Designed for your basic needs of lights, fans, television, and your electronics. Not more than that. The question is, how do we provide this limited power from the grid? The grid is providing 230 volts. And that brings us to our next thing. In India, and these numbers may vary slightly from country to country, there are these 33 kV substations from where there is a transformer, it is transformed to 11 kV, and this 11 kV is then fed towards either homes or towards offices. That's the normal practice that is used. Whenever the supply is less than the demand, in certain areas, it is a blackout is done by actually just cutting off the line from towards homes and offices. What have we done? What we have done is replace this blackout by a concept of brownout. Now, when there is not enough power available because supply is less than the demand, we say we will not completely cut. There is still supply available, but we will only provide 5% of the power on the grid, 5–6% of the power. We will provide this power at a lower voltage. We put an additional transformer. We just bring down the voltage as if to signal, to actually signal to each home that now the brownout situation exists. And then we provide this goes towards homes and offices. The industry essentially see low voltage and just cuts it off. There is a low voltage cutoff that we have brought into the units and it just cuts off. Homes, now this gets 11 kV to 4.4 kV. It goes to a distribution transformer and finally lands up at home either at 230 volts or 92 volts. The 230 volt directly goes to the 230 volt appliances through the meter. And whenever the power cuts takes place, whenever the brownout takes place, essentially a low voltage detector cuts off the AC power and no more AC power flows. So it is brownout is same as blackout as far as the AC power is concerned. But what about a DC power? Here we have introduced within the meter a programmable DC power unit, which takes input either from 230 volts or 92 volts, but gives out 48 volt DC, 24/7, meter and give out. This is what we have done. Fairly simple thing, but this essentially gives you, irrespective of however shortage is there is a limited amount of DC power always available. The question is how limited. And believe it or not, we have actually experimented only with 100 watts. Now, what can one do with 100 watts at each home? Well, we have seen that particularly in a small home, 3 lights, 2 fans, and cell phone charging can be actually done by 100 watts. And we can, instead of that, instead of 1 fan, we can switch off and we can put a television. And we did a detailed calculation, made these lights, commercialized this, made the fans, got the large commercial companies to make it. In fact, added some interesting things that we don't even have switches, we just have a remote now. A single remote which manages all these lights and fans. And we talked to the television providers. Well, they said, well, they can provide us, they have anyway 48 volt or 19.5 volt. They will bring out, so we got them to do that. And then we built up the DC-DC converters for the cell phones and laptop chargers, and we were able to actually start providing this. We built it, we installed it, and started using it. Now, the interesting thing is 100 watt of power is small enough, such that even in the worst situation, you can still continue to supply that. Maybe another 5 to 10 watts loss, but you still can actually do that. It actually amounts to 2% of the power that is generated in peak. Even in the worst case, it is not more than 4% power. The only question was, but what if you want more? 2, 3 lights, 2 fans is all right, but what if I want a little more? Well, that's where we added one more thing. This was already there. The lights and fan, the meter was there. What we added was a small solar unit. In the home, you just add a small solar unit, low cost unit, and it directly connects to the DC. And that 100 watts suddenly becomes 150 watt, 200 watt, 250 watts, and even large upper middle class homes, if they are not using air conditioners and other things, that will be there only when the power is there, can actually now use enough number of lights, fans, your large televisions, and also your other electronics. So this is something that we did, and of course, since we were doing it in 2013, we added a Zigbee, essentially made them a smart meter. Now, there is anyway push to replace the ordinary meter with smart meter, and this is what we are able to do. And we started installing it. The solar can be incrementally added. The important thing is every device can be incrementally purchased, light and fan. You don't need to purchase everything. You initially start with 1 light, 1 fan. Then as you have a little bit of money, you can start adding more. And you can add DC also immediately. Of course, AC is always available whenever power is available. So this is something that we have actually done. Installed it on campus first. Now we are working with 5 state electricity board doing some slightly larger pilot, and hopefully by middle of next year we will go full-fledged commercial. Well, what does the policy relevance of this is? It requires minimal investment from either government or citizens. Important things that citizens can buy things incrementally. Some small 3,000 rupees, something like close to $50, we are able to now provide this kind of new meter, and the point is it's a smart meter. So that anyway there is interesting time of day metering is possible. Minimum change in infrastructure, and that can actually be done. It saves power because suddenly it promotes DC technology, and and DC devices, suddenly our power requirements at homes goes down. Same thing, at least 2 times power. We have seen that about 2.2 to 2.3 times power. Yes. It provides thrust for decentralized solar power generation. Most homes will be able to put 500 watts, and if 100 million homes put 500 watts, we are talking about 50 gigawatt being installed. And this will happen in 1 year or 2 years once we get something like this, because you've created a huge pull for solar unit. And could help manage subsidy. That's a very important thing. Today, the electricity boards are not allowed to charge more than 5 rupees, and as a result, they are going red. Now, the politicians can now say, well, this 100 watts will be subsidized. The AC will be put to market rate. Suddenly, everybody will bounce back. And of course, it will create a huge citizen vote. Now, this is what we are doing as far as the home services. We are also working on commercial buildings. Now, in India, if you take away the lights, fans, and electronics, what is the next most important thing in commercial building? Cooling. There is no heating. Now, the most interesting thing about cooling is that there is a natural load-demand match between the sun and the cooling requirement. Stronger the sun, more the cooling requirement. If I use solar, I can generate more power at that time. Can I use that? Get rid of my transmission and distribution losses, and at each place can I add that and gradually shift to DC, and this is what we have been actually doing. Of course, evenings is a little bit of problem in this, but most offices do close 6 p.m., 7 p.m. Of course, some of them go on till 9 p.m., but hopefully, I know the journalists work till late, but hopefully this can push people to start using a little bit early start, when the sun is there, work, and can get things going. There are, however, we have been just blindly copying what is going on in the West. So what happens? A typical solar generation, and for example, some of the states have really gone and say we have installed it, put everything at the rooftop, and it connects to the main grid and drives the electrical load. The problem is, whenever power fails, main grid fails, the solar is cut off. Why is solar cut off? It took me some time to understand. It's very simple. Because grid is an infinite grid, and whatever solar produces, solar fluctuates. Whatever solar provides, the remaining thing is provided by the electric grid, because the load is also uncontrollable. So therefore, whenever the grid fails, you actually have to match the source, the solar and the load, instant to instant, and there is basically no mechanism to do this. So you just cut it off, and you waste the solar energy. So what we started doing what is called load control. Whenever power goes off, we started putting smart controllers, our smart grids. And some said, well, I will partially cut off the load. And then we started adding that we'll also add a small battery bank and a small diesel generator and manage it in such a manner that it will really be running and utilizing solar 24 by or whenever the sun is available. And then we started shifting to DC, particularly this DC for electronics. And now we are starting to experiment with DC for coolers and air conditioners. We have started building air conditioners and coolers, and suddenly the whole thing starts very different. The whole economics. We of course are working with data center, but data centers are small component of the total usage still. And the smart controller vocabulary changes, because what we are talking about is something very different from what has been done in the West. Because first we have sun for very, very long hours. And that's, I know I need to just go last slide. The 20% of our power is used by agricultural purposes. And that is again huge. We have about 10 million pumps active today. And they use huge amount of power. Now, significant saving possible because of these are basically subsidized electricity. One of the problems is that most of these pumps have been designed assuming that power will be available only 1 or 2 hours, rural areas. So they are over-designed. But when you actually run it with solar, you can run it for 12 hours and at least 6-7 hours of peak hours. So your whole economics changes. You need smaller pumps. And if you are able to design that smaller pump and with solar with variable frequency drive, which we have actually been doing, and you directly drive the pumps, you really don't need to connect them to grid at all. The question that was asked me, what if it is not sunny, if it is raining? Well, if it isn't raining, then the crops don't need water. Again, we are using the load demand match, and we have found this. So it's a kind of different DC. It's a DC, solar DC, through a variable frequency drive, starting to put that. And of course, we are now also experimenting with drip irrigation, which reduces the power consumption. Water will be our next major problem, and we need to move in that direction, and that is what we have started to do. So what are the challenges? Well, the challenges are we need standardization of DC. Actually, at home, we started with working 384 volts. We were very worried about the kind of shock and other things that it can possibly need. And then we moved to 200 volts, still it was not enough. Finally, actually, we came to 48 volt DC. It is used for telecom. It is something that pretty much, our homes are not that large, small homes. The existing wiring can support 48 volts with about 2% to 3% losses, so that works out quite well. And the other important thing was that if I was using 384 volts or 200 volts and then using my cell phone charger 5 volt, I needed a 3-step down. My DC-DC converter was not very efficient. At 48 volt, I can actually make it very, very efficient. So what we started talking to the Indian electronic manufacturing companies, why don't we make 48 volt DC as a standard and let laptop instead of 19.5 volt have a 48 volt standard. We can't go to 24 volt. We have thought about it. Then we will have to replace all that because our wiring will result into huge losses. We believe that 48 volt and 384 volt need to work together. 384 volt is great for bringing in the power for maybe large applications like data centers. 48 is great for lights, fans, and electronics. We need to standardize both of them. We need the right protection for all of them. 48 volt fortunately does not require as much protection, but even the smallest protection can we make it low cost. Needs standardization of plugs. I think for too long we have been working with 40 different variety of plugs. We have, for example, couldn't find the best plugs. So what we found that US 110 volt plug is not used in India. We actually are using it for 48 volt. Now that's a temporary thing that we are doing because the plugs are available in plenty, and at least we have got a standardized plug which works quite well. So that's what we are doing. But I think this is where the efforts are required. My feeling is that if we do all the kind of things that I'm talking about, there is enough innovation can be done. You saw the innovation that I was presenting in terms of providing 24/7 power. I think we can start changing the scenario. There are enough of us, billions of people, living in what is called emerging economies, which can contribute very significantly and can start changing things. Thank you very much.